and welcome to another video. Today it's Advent of Code. It's that time of year again, and I really want to see your solutions, so leave those in the comment section down below. If you want to support the channel, there is a link in the description to different affiliates where you can get great deals on things, and there's also a donation link if you want to donate a coffee to me in order to improve the quality of the channel. Day 16, Reindeer Maze. It's time again for the Reindeer Olympics. This year the big event is the Reindeer Maze, where reindeer compete in the lowest score. You and the historians arrive to search for the chief right as the event is about to start. It wouldn't hurt to watch a little, right? The reindeer start at the start tile, marked S, and facing east, needing to reach the end tile marked E. They can move forward one tile at a time, increasing their score by 1, but never into a wall. They can also rotate clockwise or counterclockwise 90 degrees at a time, increasing their score by 1,000 points. To figure out the best place to sit, you start by grabbing a map, your puzzle input, from a nearby kiosk. For example, there are many paths through the maze. By entering any of the best paths, you incur a total score of 7,036. This can be achieved by taking the total of 36 steps. And the question is, analyze your map carefully. What is the lowest score a reindeer could possibly get? I'm gonna do this off camera because actually just recording this intro is a pain. I have slept very little this night due to not my health reasons, but due to family. So I'm gonna do this off camera. I don't have the energy to keep this up for hours. Sorry, but I'm gonna end up by reporting my findings and also the actual code that I wrote. I will go through the code, but I will not do any live coding today. So, see you later. And we are back. And the first part went pretty fast because we wrote this last year as well. So, maybe this is the correct implementation. Let's check. We now got that big value. Let's put that in and see. No, it's too high. As I said, I'm tired. I forgot to reset the set, so... And now I got the right result for the other test case we had. So let's see if we get the right result here. If it ever completes, that is also an option, that it doesn't complete. Sometimes it's good to take some time to think about things, and I maybe created a very efficient way of getting this. So let's go to Reindeer Maze here, 16, and input this value and see what you get. Yes, you get a gold star, I get a gold star, everybody gets a gold star. So, what did I do? Let's go into part 1 here. So first we created this map where we had the width and height and the start position for our expedition to find the path through the maze. Then I created a maze of integers, and I started here and just added into the maze. And for every place that there were a wall, I said this is -1. If you have a start position, I fetch that start position, and if it's an end point, it's a -2. And then for all the empty space, I say that this is infinitely far away from the end. So I start over there, and then I go in and move into the map and count and see what I can find. So when I move into the map, I send in the start position, the width, east, because that's the starting direction we went, and then 0 points, because that is where our start is. So then we go into this map, and we first figure out that they are not at a wall in this case, and we are not at the end position. So those are very important here. Then we check this position and see, is this smaller, this position here, is that smaller than current points that we are bringing into this? So have we already been here with a shorter path? Then we will also return max value. Otherwise, we will set the current amount of points to this position. So if we ever get here again, we will know that there is no shorter path because we have established that already. Then we will go for each direction. And here we will look at the first direction, north for instance. We will go east, west or north. So we can only turn in one direction. And if we continue north, we just add an extra point. And if we need to turn, we will add 1,000 points plus the extra point that we do in order to go in that direction. And when we have moved in all those directions, we take the minimum value of all these paths, and that is what we return. And then we do that for east, west, south, and so on. And if we don't get the direction, we will just return the maximum value. We'll never get there. So this is my short implementation here, and it is really fast because I first ran this, and this has been running for the whole day pretty much, and now I got the result instantly or almost. So this is a pretty good solution for this one. So let's go back here to part 2. Now that you know the best paths look like, you can figure out the best spot to sit. Every non-wall tile, S, I, S dot or E, is equipped with places to sit along the edges of a tile. While determining which of these tiles would be the best spot to sit depends on the whole bunch of factors. How comfortable is the seat area? How far away from the bathrooms are, whether there are a pillar blocking the view, etc. The most important factor is whether the tile is on one of the best paths through the maze. So you need to determine which tiles are part of any best path through the maze, including S and E. In the first example, 45 tiles marked O. That are the part of the least one of the various best paths through the maze. The second example, 64 tiles, are the best, at least one of the best paths. Analyze further. How many tiles are part of least one of the best paths through the maze? In this example, there are 45 tiles marked O that are part of least one of the various best paths through the maze. So we're pretty much gonna continue using this calculation that we have and try to figure out how many tiles there are instead. And I guess we're using the same examples. So I'm gonna do this with a little bit of playing around with the numbers here. And we are back, and I might have figured out how to do 16 part B of the advent of code. So let's run this and see what value we got. So this got a stack overflow because we are going too far. That's no good. And we are back for day 16, and I might have a solution for this one. I've tried a bunch of different things. The solution I got here is 520, so let's see if that is correct. Yes, you get a gold star. I get a gold star. Everybody gets a gold star. So what did we do? So the premise here was that we moved around the map, and then we needed to figure out all the right solutions and which places we visited during the right solutions. And the difference I did here is that I have this move in map, and I added this visited as a visited point, and then I print out the number of visited places. I also have this draw map so I can actually see what happened. So I use that for the small result. And then I went through and did this visited here. But I realized after a while that first off, you need to have a couple of new sets that you put in values into. And then I went through all these three, and I find the minimum value for all the different directions. And then if any of the directions are the same as the minimal value, then those are also available visited spots. So I put those into my visited array. The current thing that I'm visiting now, I also add to the visited array. And that works pretty well if you do that in all directions. The only problem is when you get to a point where you get into a particular site from two different directions, and the one side you have one less turn, but it's still fine to do that turn because you if you had done the turn in both directions, then you had ended up in the same place. So the difference I did here was pretty much that I add an extra turn. So if either the current points that I have now is smaller or is larger than the map position that I visit, and I also don't have exactly the same number of points as the current position plus 1,000 points, because then I'm also in a good state, because one extra turn would make it right. And if I come from a different directions, I might be able to go just forward. So that is also allowed if I can, instead of turning, move forward. So that is what I tried. I also tried to move in the different directions and adding this particular rule in just one direction, because I did it first down here with an extra if statement. But if I did that for all four, I got a too deep structure, so I ran out of stack. So I couldn't do that. But I think this was pretty ingenious to just check the extra 1,000 up here. So I check, is this correct, or have I ended up here with one less turn? Then it's fine as well. So this was with one extra turn, it turns out. So this was day 16. I hope that you found this interesting. I hope that you liked this video. Give it a like, share it with your friends and colleagues. And I would love to see your solutions in the comment section down below. And if you haven't subscribed yet, please do that. And I really hope to see you in the next video.